21. A 5-kilogram block is set into motion upon an inclined plane with an initial speed of 8 meters per second. The block comes to rest after traveling 3 meters along the plane, which is inclined at an angle of 30 degrees to the horizontal. For this motion, determine A, the change in the block's kinetic energy, B, the change in the potential energy of the block Earth system, and C, the frictional force exerted on the block assumed to be constant. D, what is the coefficient of kinetic friction? So the first thing I did was just draw a diagram, and we have the normal force, the mg, we have the 30-degree incline, we have 5 kilograms of the block, and we have the frictional force opposing motion as it's moving up the incline. We have the initial velocity of the block is 8 meters per second. It travels 3 meters, and at the end of the 3 meters, it comes to rest. So first, the change in kinetic energy, A. All it is just 1/2 mv squared of the final minus 1/2 mv initial squared. And we don't have any final energy because it's at rest, so that's 0 minus 1/2 m, which is 5 kilograms, times vi squared, which is the initial velocity, which is 8 meters per second. So we get negative 160 joules. That's how much kinetic energy it lost here to here when it went from 8 meters per second to 0 meters per second. And now the change in potential energy is just mg delta h, same concept as the kinetic energy. So we're assuming that this, wherever it starts on the incline, that's 0, and then we're just looking at the displacement after 3 meters. Well, we only know that the hypotenuse of it traveling is 3 meters, and we do know that the inclined plane, the angle between the hypotenuse and the horizontal, is 30 degrees, which means if we want to find this vertical distance it traveled, all we have to do is sine 30 degrees times 3 meters, which is 1.5 meters. And then we plug that back in. So mg is 5 kilograms times 9.8 meters per second times 1.5 meters. You get that the potential energy from point A to the final point is just 73.5 joules. So now we're looking at the friction force exerted on the block, which is assumed to be constant. And so we know friction is going up against motion. But the frictional force, what we can do is just find the work that was done by friction and then divide that by the distance, which is 3 meters, because we know that force times displacement equals work or change in energy. So if we want to find the force, we can just do change in energy divided by this distance. So we know the change in energy. We see here that the change in energy is just the adding of these two forces, because these are the only, these two energies, because kinetic energy and potential energy are the only energies in play. So what we can do is 73.5 joules plus negative 180 joules, right? We have the potential energy it gained plus the kinetic energy it lost equals the frictional force over 3 meters. So this is 80. This is negative. So if you add this together, it's negative 86.5 joules. That's how much total energy was lost because of friction over 3 meters, because that's the distance it traveled, which is negative 28.83 newtons. So the work done by friction is 28.83 newtons. And then finally, they ask us the coefficient of kinetic friction. So we know, I just redraw the diagram. Friction is going that way. So friction is just coefficient of kinetic friction, because it's moving, times the normal force equals the work done. So 28.83 newtons. And so what we can do is just normal force minus mg cosine 30 degrees is just, we're just finding the normal force, and this is just the sum of the vectors, sum of the forces in the y direction. So normal force equals mg cosine 30, and then we just did the normal force, the coefficient of kinetic friction times mg cosine 30 equals this frictional force. Sorry, this is not the work done by friction, this is the frictional force, which we solved for in the previous problem part. And so coefficient of kinetic friction equals 28.83 newtons, that's the frictional force we solved for before, over mg cosine of 30. So we get the coefficient of kinetic friction is 0.679.